Welcome to lesson 110, solve systems of equations by elimination. So we've looked at these. Here's our objective. Pause the video here and read over this slide. Here's our vocabulary. You can pause the video and read over this slide. Some rules and notes, some pictures. So basically, when we're talking about systems of equations, we're talking about two lines, and they do three things. They intersect at one spot, they never intersect, or the lines are on top of each other. They're the same line. So that is the big idea with systems of equations. Okay, so let's look at our first example. So we're going to use the elimination method. And what that means is we are going to eliminate one of the variables. And then how do we do that? Well, we got 2x and 2x, and we got y and y. Now, you know from earlier lessons that if there is no number in front of a variable, we put the number 1 in front of it. Since this is plus and minus, we know that plus 1 minus 1 are opposites, and they will go to 0. So if we add these two equations, 2x plus 2x is 4x. 1 plus negative 1, or 1 minus 1, is 0, and 5 plus 11 is 16. And we divide by 4 on both sides to get the x, and the coordinate for x is 4. Now what we have to do is stick this 4 back into both equations and make sure that it works. So you go 2 times 4 plus y equals 5. And then you go 2 times 4 minus y equals 11. And you solve and you make sure you get the same y coordinate. If the y coordinate is different, either your math is wrong or you have what is called no solution. And let's look at what we have. 8 plus y equals 5. Subtract 8 from both sides. And then y equals negative 3. Okay, now let's look at this one. 8 minus y equals 11. Subtract 8 from both sides. Negative y equals 3. And you're saying I'm done. You're not done. The coefficient in front of y has to be positive. So now we got to divide the whole thing by negative 1. And y equals negative 3. So we get the same y value for the x value. So this tells you that the point of intersection is 4, negative 3. So however these lines work out, if I was to draw this on a graph, and this was 4 and this was 3, both of these lines would intersect at this point. And that is the big idea. You're looking for the point of intersection. Okay, so the first thing you got to do is look at your coordinates. Look at your variables. You got 5 and 4, which are different coefficients. That's the number in front of the variable. So what I'm going to do here is I'm going to subtract. 2 minus 2 is 0. Negative 5 minus negative 4. Remember, two negatives in a row become positive. Becomes negative 1. 25 minus 24 becomes 1. Divide by negative 1 on both sides, and y will equal negative 1. Okay, now what I have to do is put the y coordinate into both equations. So 2x minus 5 times negative 1. Always put your substitute into parentheses so you keep your sign straight. Then 2x minus 4 negative 1 equals 24. And then solve both equations. 2x plus 5 equals 25. Subtract 5 from both sides. 2x equals 20. X equals 10 after divide both sides by 2. Now for the other equation, 2x negative 4 times negative 1 is positive 4 equals 24. Subtract 4 from both sides. 2x equals 20. Divide by 2, x equals 10. Now what does this tell you? Your point of intersection is 10, comma, negative 1. And that's what you're looking for. And that's all we do in systems of equations. And so you look for to use the elimination method when you have the same coefficients on one of your variables. So the last example we looked at a y coefficient, and this example we looked at the x coefficient that was the same. Okay, so let's look at our third example. Tanisha pays $49 for one pair of jeans and two shirts. The next day she returns the two shirts and buys two more pair of jeans and pays an additional $26. What is the cost of one pair of jeans and one shirt? Okay, so now how do we make this? So we have jeans and a shirt. So one jean plus two shirts equals $49. And buys two more pair of jeans and pays an additional $26. So now she has two more pair of jeans, makes three jeans. And pays an additional $26. So 49 and 26. 49 and 50 and 26 makes $75. Now see how this worked out? She returned the two shirts, so that's 0 shirts. So now, this is easy because 3J, all we do is divide by 3. The jeans equals $25, okay? So now we stick this number in to our original equation. And now what we had to do is stick this 25 into our original equation. So 125 plus two shirts equals $49. So 25 plus two shirts equals $49. Subtract 25 on both sides. Two shirts equals $24. Divide by 2. Divide by 2. Now the shirts equals $12. One shirt. Now that we have figured out how much one shirt and one pair of jeans cost, now we had to add them together to answer the question. So what we did was find an intersection point, but now the application is to find the cost. So 25 plus 12. For one jeans and one pair of shirt, one jean plus one shirt equals $37. All right, those were our three examples. Please try the problems on the next couple of slides on your own, and I will see you at the end of the video for a recap. Okay, so now that we solved this by elimination, okay, we see that y and y have the same coefficient. So if we subtract them, 1y minus 3y becomes negative 2x. Negative 1 minus a negative, two negatives in a row become positive, so that goes to 0. And then 5 minus 7 is negative 2. Divide both sides by negative 2, and then x will equal 1. Okay, so you're not done. Now we have to stick 1 into both equations. So 1 minus y equals 5, and 3 times 1 minus y equals 7. Okay. Subtract 1 from both sides. Negative y equals 4. Divide by negative 1, because your y must be positive, and you get negative 4. So for the next equation, 3 minus y equals 7. Subtract 3. Negative y equals 4. Divide by negative 1. Y equals 4. Okay, negative 4. We get the same point. So our point of intersection is 1, negative 4. Okay, your second one. Your s's have the same coefficient. So we are going to add. And look at this. We got little fractions. So I'm going to show you a little shortcut. If I do that, it would throw off the thing. I'll do that. No, we're not going to do a shortcut, because that would throw off. 3 plus negative 2 is 1r. 2 minus 2 plus negative 2 is 0. Negative 1/2 plus 1/6. We got to do a little fraction magic here. Six is the common denominator, so times 3 over 3 equals negative 3 over 6 plus 1/6 gives us negative 2/6, which equals negative 1/3. Reduce your fractions and all that. And if you are shaky with your fractions, please go back and look at some of the videos in the numbers and operations playlist. So 1r equals negative 1/3. So now what we got to do is stick this into both equations. So 3 times negative 1/3 plus 2s equals negative 1/2. So 3 times negative 1/3 is negative 1 plus 2s equals negative 1/2. Add 1, 2s equals 1/2. Divide by 2, and then s will equals 1/4. And if I went a little too fast, please go back and do it slowly. Negative 2, negative 1/3, minus 2s equals 1/6. 2/3 minus 2s equals 1/6. So we're going to convert this to 6 first by 2 over 2. So 4/6 minus 2s equals 1/6. Subtract 4/6 from both sides. Negative 2s equals 1/6 minus, I already wrote that, didn't I? There's no reason to re-say the same old stuff. Negative 3/6. Negative 2s equals negative 1/2. Divide by negative 2 on both sides. And s equals negative 1, positive. A negative divided by a negative is a positive. And we see we have the same point. So our point, negative 1/3, positive 1/4. That is our point of intersection. Okay, let's look at problem 3. where both equations are not in standard form. So the first thing we have to do is transform these into standard form by moving the number and the variable. So this will give us 2x plus y equals 0.8, and then negative 2x, because we had to move this 2x and move this 1.4, plus 2y equals negative 1.4. And we can see that our x's are opposites, so if we add them, we know we'll get to 0. So 1y plus 2y is 3y. 0.8 plus negative 1.4 is negative 0.6. Divide both sides by 3. Y equals negative 0.2. Okay, so now that we found y, we're going to substitute y into both equations and solve for x. So looking at our first equation, 2x minus 0.8 equals negative 0.2. This is why we use parentheses when we substitute, because we have to make sure that we get the sign straight. And so first of all, we got to get our sign straight. Minus 0.8 equals positive 0.2. Add 0.8 to both sides. 2x equals 1. Divide by 2 on both sides. X equals 1/2. Okay, so now into our second equation. Let's do this in black over here. 2 times negative 0.2 plus 1.4 equals 2x. And 2 times negative 2 is negative 0.4 plus 1.4 equals 2x. Negative 0.4 plus 1.4 is 1 equals 2x. Divide by 2, divide by 2. And x equals 1/2 again. So the reason why the first thing we found was the y coordinate. So the y coordinate has to get substituted into both equations. I know the temptation for this one, because this is kind of different, is to find a y, get the x, and then substitute the x back in. That can work, and that's a way to do it, but you want to remain consistent. You want to substitute the same variable into both equations. So please be very detailed. Keep that in your mind at all times. You eliminate one variable and solve for the other. We eliminated the x's, we solve for the y. The variable that we solved for is the one that gets substituted into both equations. So keep that in mind. All right, and let's look at another problem. Problem 4. Stephen walks or bikes on short trips. Okay, so here's our variable. Walks, bikes. Last week, he walked 2.5 hours and biked 5 hours, traveling a total of 55 miles. So we got 2.5 walked plus 5 biked equals 55. Because hours and hours are the same, we ignore the hours because we are looking for our distance. And we'll come to that when we answer the rest of the problem. Traveling a total of 55 miles. This week, he walked 2.5 hours. So 2.5, he walked again, and then biked for 2 hours, traveling a total of 28 miles. What was his rate of speed? Now, rate of speed for walking and biking. Okay. Rate of speed equals distance divided by time. So let's keep that in the back of our mind. And let's solve these. So we're going to subtract because they had the same. So the walking will cancel out, and you get 5 minus 2 gives us 3. Biked. 55 minus 28 is 27. Divide by 3. So biked equals 9. Okay, so now we substitute this into both equations. 2.5 subtract 45 from both sides. 2.5 W equals 10. Divide by 2.5. Divide by 2.5. Walking is 4. Okay. Now we got to make sure we get the same thing on the second one. Subtract 18 equals 10. Divide by 2.5 again. And we can see that walking is 4. Okay, so now biking is 9, walking is 4. Okay, so because I told you to ignore hours at the beginning, if this is miles and both of these are hours, when you divide the distance miles by the time hours, you will get miles per hour for both of these things. So basically Stephen biked at a speed of 9 miles an hour and walked at a speed of 4 miles an hour. Now you can go ahead and substitute both of these numbers back into both equations and you will see that they work. So I wanted to go ahead and do the math and then come back and explain how the units worked out into these. So we ignored the hours at the beginning because we had to deal with walking and biking as our variables. And then it made a difference at the end because if you would have used hours, you would have had 2.5h plus 5h, and then you would have been able to add the h's together, and that would not have made much sense when it came down to dividing. So when you get word problems like this and they have the same measurement, time measurement or whatever measurement, you have to find some other variable to use so that you can go back in and fill in the same thing and do whatever. Most of your problems won't be like this. They won't give you hours and miles and then ask you for the speed, a third thing. So don't be confused. 9 times out of 10, the questions are really asking you, can you find a point of intersection? And most of the times they'll ask you to put it on a graph. But I thought this was an interesting problem to solve. I thought this was be relevant to you guys. All right, so that is that. And then